Now look at this. I will try to convert. First of all, let us do conversion of binary to decimal to binary. Okay, first let us do decimal to binary. That means I will take a decimal number and I will try to convert it into binary equivalent. Okay. For example, if I take a number say 37, how do I express it in binary? The rule is in binary numeric system what happens? You use basic two digits 0 and 2. Binary means 2 and binary numbers also I told you in the previous video that binary numbers are expressed in base 2, right? So what we do, we every time divide the number by 2. How do we divide? We take the number and we start dividing it and we write the quotient and the remainder of the division. So what is the quotient? What will be the quotient if I divide 37 by 2? It will be 18 2s are 36 and remainder will be 1. Remainder you write on the right hand side just like the way I am writing. Fine. Divide 18 again by 2, so you get 9. 9 2s are 18. No remainder, so right remainder is 0. No remainder means right remainder is 0. 2 4s are 8. Remainder will be 1. Write 1. 2 2s are 4. Remainder is 0. And 2 1s are 2. Remainder is 0. Now, if I divide 1 by 2, what will happen? We are not talking about a decimal point division here. Don't misunderstand. It's a pure integer division. 1. I am trying to divide 1 by 2. Can I divide 1 by 2? I cannot divide 1 by 2. So the rule says what happens when we cannot divide, we write like this. So who is the quotient and who is the remainder? 0 is the quotient, 1 is the remainder. So can I write here 0 and can I write here 1? Now, who is equivalent to 37 in binary numeric system? The equivalent will be if I write down these numbers from bottom to top. That means I got 1, then I got double 0, then I got 1, then I got 0, then I got 1. This arrow means I have to go from bottom to top, not from top to bottom. So if I write all the digits from bottom to top, what will happen? We get 1 double 0, 1 double 0, then we get 1 0 1, 1 0 1. And let me write a 2 here. That means this is the number who is equivalent to the number 37. Whatever is known to us in our daily life, the number 37 that we use, that is known as 1 double 0 1 0 1 in binary numeric system. That is how we can convert a decimal number to a binary number. Now this is a very simple conversion when we have a number like 37. But imagine I have been given a number 37.25. Okay, a decimal point is there. Then what to do? Then also the rule is same. What you have to do is in this case, integer part and the decimal part we have to deal separately. So I have already done the integer part. Okay, integer part will remain same. Only difference will come with this 0.25. My decimal part was how much? 0.25. So I can write 0.25. What I do? Take the decimal part and keep on multiplying it by 2. If you multiply it by 2, then how much are you getting? You are getting 0.50. Now from the result, what you have to do, you have to take the integer part out. Integer part is 0. So I will write here 0. Now look at this, you got, what is left out in the decimal part? In the decimal part, you got 0.50. So take 0.50 multiplied by 2. How much will you get? You will get 1.00. So take out this one. So here I will stop. Why shall I stop here? Because my decimal part is 0 0. So doesn't matter how much time I multiply 0 0, I will get 0 only. So basically what will happen? 37.25. While writing the answer, we will write it this way. 37.2510. Whatever was the decimal number called 37.25 this will be equivalent to 1000101 1001101 from bottom to top. Then we will write point. We will also put a decimal point and we will write 0 and 1. First I got 0, then I got 1. So 0 and 1. If you write 2 here to mean base 2, that means this is the equivalent of 37.25. Now here we had only 0.25, so result was obtained very easily. Always it may not be the case. For example, instead of 25, say for example we had this thing. We had say 37.625. Then what we would have done? Then my decimal part is 625. So 0.625. This is to be multiplied by 2. So what I am getting? I am getting 5 to 0, 10. This is what I am getting, right? Now, what do we do? 5 to the 10, 2 to the 4, 1, 5, and then 6 to the, I think I made a mistake, 12. Fine. So what will happen now? My integer part is 1, so I will write this 1. Okay. Now what is left out in the decimal part? 0.250. So we will write 0.250 multiplied by 2. What am I getting here? I am getting 0, 5 to the 10, 2 to 4 and 5. Okay. That's what we are getting. So I will get 0. So this is how we have to continue. Look at this. Now, supposing here I got 5. Next step, what will happen is next step, if you multiply it once again, you will get this. That means you are getting 1. The moment you got 1 and the decimal part got 0, you can stop. But imagine it doesn't stop. Okay, imagine it doesn't stop. You still have something to deal with. That means you need to multiply it once again. No need to do it. Just show the first 3 steps. That will be more than enough. Like I have done. I got the result, but if you do not get the result in the third step also, take the first 3 steps. So we can say here 0.625 will be written as 0.101. That is how we can convert a decimal number to binary number, even though if it is given in the decimal, even if there is a decimal point given in the number. Fine? This is how we can do it. Another one I will show you where we will see conversion of binary to decimal, opposite thing. Okay? How to do it? See, imagine we are given a number. We are given a number like this. Say 1, 0, 0, 1, 1. Something like this we are given. 1. Now, once the number is given to us, what we have to do? Pay attention to that very carefully. What you do at the very beginning is put some numbers here. Which numbers? Like start counting from right to left. You start counting the digits. Say this is my 0th digit. This is my first digit. This is my second digit, third digit, fourth digit, fifth digit. This is how you write all the digits. Fine. It has to start from 0. Remember, 0, 1, 2, 3, this way to increase. Now what you will do? You have to multiply this 1. Look at this was 1. It is to be multiplied by 2 raised to the power 0. This will go as a power of 2. So what are you getting here? 2, anything raised to the power 0 is 1. So I am getting 1. Now this one will be multiplied by 2 raised to the power this number 1. So I get 2. This 0 should be multiplied by 2 to the power 2. But 2 to the power 2 doesn't matter, whatever it is. Multiplying it by 0 means I will get 0. Same will be the case here. 0 multiplied by 2 to the power doesn't matter, it will be 0. Now this one, look at this. 1. This one will be multiplied by 2 to the power 4. What is 2 to the power 4? 2 to the power 4 is 16. and this 1 will be multiplied by 2 to the power 5, that is 1 into 32. So how much are we getting? 32, 42, 48, 50 and 151. If I add these numbers, if I simply add these, I am getting 51. So basically 51 is the number who is equivalent to this, right? So while writing the answer, how do I write? I will write 110011. What is given to me is the binary number, and this is equivalent to, I got my result 51 in decimal number. Okay, that is how we find binary to decimal. Now here also we can have decimal points. For example, this is given to me, fine, and imagine we have after this say 1 1 0, then what do we do? 1 1 0, 0.110 is given to us, fine. So if 0.110 is given to us, that means 51 point something will come. How to calculate that? I am just erasing this part, and it will be easier for you to understand. We got 0.110. So how do we get 0.110? So let me write it again once again. 0.110. Say here we had 00, 11, 00, 11. You know already how to do this part. What will you do? How will you do? I am repeating once again so that you can remember all together. Put the digit numbers from 0, 1, 2, 3, 4, 5. And this way we write opposite thing, -1, -2, -3. Okay? Now what you have to do is, this one, 0, will be multiplied by 2 to the power -3. This one will be multiplied by 2 to the power -2. And this one will be multiplied by 2 to the power -1. So what is 2 to the power -1? 2 to the power -1 is nothing but 1 into 1 by 2, that is half. That means 0.5. This means 1 into 1 by 4, that is nothing but 0.25, 0.25. And this one, 0 multiplied by something will be always 0, so it will be 0. So basically what you have to do, we have to sum it up along the decimal points also, this side also. If I just sum it up, what should I do? 0.5 means 0.50, that is I am getting 0.75. So whatever you got here with that 0.75, 0.75 you add. So that means supposing this one, the result will be, we got it just now, 32, we got 16, and we got 2, and we got 1. That means this was 51. We got 51 here, and we got 0.75 there. So altogether this will be 51.75 in decimal number. That is how we can calculate binary to decimal. Okay. Another thing in today's video I will show you, though it is exactly similar, it is not different at all.